Let's explore the renice and renice commands in Linux. These commands are used to manage process priorities, allowing you to control how much CPU time a process receives. This is particularly useful for optimizing system performance. The topic for the presentation is setting and changing process priorities in Linux. In Linux, every process runs with a specific priority level that determines how much CPU time it gets. Higher priority processes receive more CPU time, ensuring they run more efficiently. Lower priority processes have to wait longer, which is ideal for background tasks. Linux uses renice values to represent process priorities. These values range from -20, which is the highest priority, to +19, which is the lowest priority. The default renice value for user processes is 0. The renice command starts a process with a modified scheduling priority. It allows you to run commands with a specified priority level, known as the renice value. Regular users can only decrease the priority, meaning they can only increase the renice value. The basic syntax of the renice command is as follows: renice followed by the option in for adjustment, then the command and its arguments. For example, you can use renice n10 find/name star.log to find log files with a lower priority, or renice n5 tar czf backup. /home to create a backup with a slightly reduced priority. Here are some common usage examples of the renice command. To run a CPU-intensive process with lower priority, use renice n10 ffmpeg I input for output mp4. This command converts a video file with a lower priority. To check the renice value of the current shell, simply type renice. The output will show the current renice value, which is typically 0. To run a command with the default renice adjustment of +10, use renice find/name star.tmp. This command searches for temporary files with a reduced priority. The renice command is used to alter the priority of running processes. Unlike the renice command, renice works on processes that are already running. Regular users can only decrease the priority of their own processes, meaning they can only increase the renice value. The basic syntax of the renice command is renice priority followed by either the P option and the process ID, the U option and the username, or the G option and the process group. This allows you to adjust the priority of processes based on their ID, user, or group. Here are a few common usage examples for the renice command. To change the priority of a process by its process ID, use renice 10p1234. The output will confirm the change, showing the old and new priorities. To change the priority for all processes of a user, use sudo renice 5u username. Note that you need superuser privileges to change the priority of processes owned by other users. To lower the priority of multiple processes at once, use renice plus 5p1234 56 78 90 12. This command increases the renice value by 5 for the specified process IDs. To check the process priorities, you can use the ps command. The command ps opid renice com will display the process ID, renice value, and command name for each running process. For example, you might see an output showing the bash shell with a renice value of 0, Firefox with a renice value of 10, and Chrome with a renice value of 5. Alternatively, you can use the top command. In the top output, the ni column shows the renice value of each process, providing a real-time view of process priorities. When should you use priority adjustment? It's a good idea to run CPU-intensive tasks at a lower priority during work hours to maintain system responsiveness. Interactive applications can be given a higher priority to ensure smooth performance. Lowering the priority of background tasks, such as backups, can prevent them from interfering with other processes. Adjusting priorities can lead to better overall system responsiveness. Remember, renice is used to start a new process with a modified priority, while renice changes the priority of running processes. Lower renice values mean higher priority, with the range being from -20 to +19. Regular users can only decrease the priority of their own processes. Process priorities help optimize system resources, but should be used with care to maintain system stability. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.